Why are temperature reservoirs crucial for engine efficiency? Imagine trying to run a race with a heavy backpack. The heavier it is, the harder it is to move quickly. Engines work the same way with heat and temperature differences. They need a hot place and a cold place to work efficiently. These are called temperature reservoirs. They are like the starting and finishing lines in a race, creating the conditions for the engine to do its best. In a heat engine, heat flows from a hot reservoir, like the gases inside an engine after combustion, to a cold reservoir, such as the surrounding air or a cooling system. This flow of heat is what makes the engine turn and produce work. The bigger the difference between the hot and cold reservoirs, the more work the engine can generate. Think of it like a steep hill versus a gentle slope. The steeper the hill, the faster you can slide down. The idealized model, called the Carnot engine, helps us understand this better. Its efficiency depends on the temperatures of these reservoirs. The formula is simple. Efficiency equals 1 minus the temperature of the cold reservoir divided by the temperature of the hot reservoir. This means if the hot reservoir is very hot and the cold reservoir is very cold, the engine can be more efficient. But if both are at the same temperature, no work can be done because heat won't flow. In real engines, the hot reservoir might be the combustion gases that are very hot, and the cold reservoir is the cooling system or the outside air. The engine takes in heat from the hot gases, turns some of that heat into motion, and then releases the remaining heat to the cooler surroundings. This process depends on maintaining that temperature difference. Without it, the engine can't work. The second law of thermodynamics tells us heat naturally moves from hot to cold. Without two reservoirs at different temperatures, heat won't flow, and no work can be produced. That's why the cold reservoir must be above absolute zero, the lowest possible temperature. If it were at absolute zero, the engine could theoretically reach perfect efficiency, but that is impossible in practice. So, in simple terms, temperature reservoirs are essential because they create the conditions needed for heat to flow and for engines to do work. The larger the temperature gap, the better the engine can perform. Improving engine efficiency often means making the hot side hotter and the cold side cooler, but within the limits of what physics allows. This balance is what keeps engines running smoothly and efficiently.